We're beginning to look at trigonometric identities, and we started off where we mentioned the quotient identity, the reciprocal identity, Pythagorean identities, cofunction identities, and negative angle identities. All of these are different identities that we can use involving trigonometric functions that would help us to solve equations or solve values. And we're going to start here by using trigonometric identities. And we're asked here in this example to find the sine of theta if the cosine of theta is 1/3 and theta is greater than 270 degrees and less than 360 degrees. Well, let's see. Let's deal with that. Let's deal with that 270, 360 first. That would mean that theta is in the fourth quadrant. And as we know by now, we should, all students take calculus. In the fourth quadrant, the cosine and its reciprocal, the secant, are positive. But all the others are negative. The sine, its reciprocal, the cosecant is going to be negative. The tangent and the cotangent also are going to be negative. So whenever we find this sine of theta, and we're getting ready to work on that here in just a moment, we know that that sine of theta must be negative, and we want to kind of hold on to that thought for a while. But we'll get back to it. Now, one of the identities that we've got is the Pythagorean identity. And I think we can use this to help us find the sine of theta when we know the cosine of theta. Now, the Pythagorean identity goes like this. It says that the sine squared of theta plus the cosine squared of theta equals 1. And we could rewrite this if we're trying to find the sine of theta as the sine squared of theta equals 1 minus the cosine squared of theta. And that's what we're going to use, this Pythagorean identity, the sine squared of theta equals 1 minus the cosine of theta, to help us find the sine of theta when the cosine is 1/3. So let's go about doing that. So we've got the sine squared of theta equals 1 minus, and what's our cosine? Our cosine here is 1/3, 1/3, but we're going to square it because that's the cosine squared of theta right here. Well, let's do that. We got the sine squared of theta now equals 1 minus, and when I square 1/3, I'm going to have 1/9. Now, if I'm going to subtract 1/9 from 1, I'm going to have to rewrite this 1 as 9/9. That's 1, correct? Minus 1/9. And so now we can say that the sine squared of theta is equal to 8/9. But notice, this is the sine squared of theta. So I'm going to have to take the square root of both sides of this. So we got the sine of theta then is going to equal, and I'm going to put my roots in both in the, well, let me do it like this. First, we're going to have the square root of 8/9, which then I'm going to rewrite as the square root of 8 over the square root of 9. And I'm going to continue rewriting this to where, because I see 8 and I know 4 times 2 is 8 and 4 is a perfect square. The square root of 4 times the square root of 2, that would equal the square root of 8 over, and I'm going to go ahead and take the square root of 9, it's 3. All right, and then we've got square root of 4 is 2 times the square root of 2 over 3. Now all of this could be written as plus or minus all the way through. Let me just do that. Plus or minus, plus or minus, plus or minus. Now I'm going to ask myself about the final question. We said this was in the fourth quadrant. And in the fourth quadrant, the sign is going to be negative. So therefore, the sine of theta, when the cosine is 1/3, and theta lies between 270 degrees and 360 degrees, therefore being the fourth quadrant, that the sine of theta then must be equal to negative square root of 2 square root of 2 over 3. All right, well, we use the Pythagorean identity to find the sine of theta. Shall we look at one more? This one's got a little bit of a difference to it. All right, this time we're asked to find the secant of theta if the sine of theta is negative 2 over 7, and theta is greater than 180 degrees, but it's less than 230. So theta is in quadrant 3. Now, quadrant 3, let's see, do it like this, quadrant 3, all students take calculus. And sure enough, the sine of theta is going to be negative in quadrant 3, and so is the cosine. Now, why do I care about the cosine? Well, the secant is equal to, because it's a reciprocal identity, to 1 over the cosine. Now, since I know the sine of theta, and we got a Pythagorean identity, right? We got a Pythagorean identity that we just used, that the sine squared of theta plus the cosine squared of theta, cosine squared of theta equals 1. I can use this, the Pythagorean, to find the cosine of theta. And once I find the cosine of theta, well, the secant is just the reciprocal of the cosine, so it's a reciprocal identity. All right, you ready? Let's find the cosine of theta first. So we can then say that the cosine squared of theta, don't forget your squared, this is part of your Pythagorean identity, is now equal to 1 minus the sine squared of theta. All right, you can raise your hand if you understand how I got here. I do. Okay, all right. Well, let's fill in this value for the sine of theta, and then we're going to square it. So the cosine of theta is equal to 1 minus negative 2 over 7 squared. And the cosine squared of theta is now going to equal 1 minus, let's see, the square root of negative 2, negative 2 squared is 4, 7 squared is 49. So when we square the sine, which is negative 2 over 7, that comes to 4 over 49. And we got to subtract that from 1, which of course means I need to convert 1 to 49 over 49. So I got a common denominator, and we're going to subtract from that 4 over 49, which means that the cosine squared of theta is 45 over 49. Now we want to take the square root of both sides of this, so that the cosine, not the cosine squared, but the cosine of theta is now equal to the square root of 45 over 49. And once again, I'm going to break the numerator and the denominator into its parts. So we got the square root of 45 over the square root of 49. Let's see. Square root of 45. Well, 9 times 5 equals 45. So I can now continue on simplify this to the square root of 9 times the square root of 5 over, and the square root of 49, I'm going to go ahead and take the square root of that because it's 7. Now that equals, let's see, the square root of 9 is 3. So our cosine is equal to 3 times the square root of 5 over 7. That's our cosine. But we're trying to find the secant. Well, all we got to do is take this cosine. Well, let's do it like this. We'll do it one step at a time, make sure we're all cool. So we can now say that the secant is equal to 1 over 3 square root of 5 over 7. But that is also equal, if I make that the reciprocal, where 7 over 3 square root of 5. Well, we're almost done. Not quite. We got to rationalize this thing. So let's multiply this by the square root of 5 over the square root of 5. And once we do, we've got, remember I should have plus or minus is all where this square root is going to come in handy. I got plus or minus 7 square root of 5 over, well, let's say square root of 5 times square root of 5 is just 5. 3 times 5 is 15 over 15. Now, last piece. I'm down to this. The secant of theta is equal to, we're saying, either plus or minus 7 square root of 5 over 15. Now, what quadrant did we say we were in? We said we were in this third quadrant right here. We're in quadrant 3. And in quadrant 3, both the sine and the cosine are negative. Only the tangent and cotangent functions are positive, and that's because both the sine and the cosine are negative. So our secant of theta, when the sine of theta equals negative 2 over 7, and theta lies in quadrant 3, it's greater than 180, it's less than 270, it's in quadrant 3, is going to be negative 7 square root of 5 over 15. Now, all of that probably deserves a big Shazam.